Yo guys, welcome back. So we are doing exponentials and hyperbola, but of course, as you can see from the screen, we have a hyperbolic example. So let me do this because it's not. Yeah, we have a hyperbolic question, hyperbola. So yeah, let's get started. So this is a hyperbola nicest thing. They gave us a formula, so we don't have to stress about much. They also gave us what? They gave us the graph, what it looks like. Maybe before I start, let's just try to make sure with everything that we know. Let's try to see if the graph makes sense. Ne? So let's start with Q. Q is -2. That -2, it tells us that our graph it shifted 2 units downwards, right? Because remember that 2 is what? That 2 is your Q, which is what? Your vertical shift. So if Q is -2, that means the graph shifted 2 units downwards, and we see that shift right here. That tells us that it has to be y is equals to what? Is equals to -2, right? And for P, we have a P. What did I do though? I didn't lock this one. I didn't lock that one. Cool. That is Q. Cool. Now for I'd like a different color. For we have P, that is P, and P is -1. But we remember, if it's -1, then the exact value is not -1 for P, but it is +1. With +1, it's saying from the original. Remember now that P is what? Is it horizontal or vertical shift? It is horizontal shift. That means our graph it shifted 1 unit to the right, and we see that shift right here. We moved from here, the origin went to the right. That means this line, it has to be x is equals to 1, and therefore this coordinate this coordinate right here is gonna be what? It's gonna be 1 and -2, right? Because it's the intersection of your two asymptotes. So we are good. Then we look at A, we have a negative value of A, right? And for negative values of A, remember we said that it's gonna be because of that negative. There was this thing that I was doing. I was like, no, they're gonna form something that is of a decreasing tonton. I don't know how to term this thing, but I will just show you right now. Maybe increase the font for red. Yeah, so you see that this is kind of how the graph looks like. We have one this side, the other one this side, having that decreasing function tonton. Because this line that we have here, this line, it is a decreasing line, so is this one. So it makes sense that A is negative. And there was with this other particular thing that I said that if A is negative, then you have your graph on the second quadrant and on the third or fourth quadrant. Second quadrant and fourth quadrant, which is what we have here. But also remember that it's not always like this, because sometimes because of the shifts, you can have your graph. For example, just say your graph shifted 10 units, right, to wherever, and 15 units to wherever. So say there were one vertical shift 15 units, one horizontal shift 10 units. It doesn't matter whether it was up or down, left or right, but it was 10 units and 15 units of shift. Those shifts, they literally they literally take your graph outside those. You will find your graph being on the same quadrant. You know what I mean? So I'll put a pause on that, not even a pause, a full stop. Now we're gonna move on to answer these questions. Cool. So let me erase, I think these are not important. So first question, write the coordinates of A. We have already done that. Remember, A is the intersection of what? Of your two asymptotes, right? So you have the font. Let me bring it to the original. I think I can come back to this. So A is gonna be what? Coordinates of A, it's gonna be A. we have 1 and minus 2, right? These are the coordinates of A. I'm guessing there is just 1 mark for each. Now the other thing is like determine the coordinates of x and y intercepts. Okay, and that one is 5 marks, so we're gonna have to calculate. And yeah, I'm so sorry. Yeah, and one thing we already see here is that we have what? We have y-intercept right here on the side. We have x-intercept on the side. So let's go on with it. It's 5, 1, and 2. So the function is minus 9. Is it f or g? F of x is equals to minus 9, x minus 1 minus 2. A lot of minuses. I could say a lot of minus. So this side I will be doing the x-intercept, intercept. This side I'll be doing the y-intercept, right? Maybe let me just say set, and then this side I'll also say intercept. All right, so x-intercept, remember y equals to 0, right? So let's get on with it. Y equals to 0, so you have 0. I don't know. Okay, cool. Yeah, you have 0. No, let me use a black pen. Yeah, black pen is much louder. Yeah, cool. So I'm gonna have 0 is equals to minus 9, x minus 2 minus 1, I mean minus 2. Then I have positive 2 minus 9, x minus 1. Remember there was this trick that I showed you guys on the previous videos. So we could just take x minus 1, and say we have minus 9 over 2, right? And therefore x is equals to 1 minus 9 over 2, right? And the answer is gonna be what? The answer is gonna be let me check it. I'm thinking it's gonna be 3.5 minus 3.5, 1 minus 9 over 2, right? So minus 3.5, so minus 3.5, right? Yeah, so and let's test it out, ne? Let us test it. So we have negative 9, and we have the x value, which is minus 3.5 minus 1, right? The answer is 2. Then we minus the 2. What do we get? We get 0. So it verifies this number we have here to say this is the x-intercept. So the x-intercept, you would say it's minus 3.5 and 0, right? There we go. Y-intercept is always quite easy. So y-intercept x is equals to 0, so we could say y equals to minus 9, 0 minus 1, minus 2. That is what? You have minus 9 minus 1 minus 2. You have 9 minus 2. You have 7. That means for y-intercept you have what? You have 0 and 7, right? If I put these numbers here, this number here, it's the number here is what? That is 0 and 7, and the number here, that is what? The number here, that is minus 3. Let me just say what is 3.5? Let me see. No, it's 7. Yeah, 7 minus 7 over 2 and 0, right? So yeah, let's move on. Check, they say this question is quite lovely, ne? This question is quite lovely. We did something like this when I was doing the content for hyperbola. So write down the equation of the axis of symmetry of f that has a negative gradient. So remember that we have two axes of symmetry for hyperbola. We have two of them, and one of them has what? Has a negative gradient, the other one has a positive gradient. So here they ask us to find the one with negative gradient. So that case, that's 5, 1, 3. That case, the formula is gonna be just y equals to minus x plus c being a constant, and the negative is a negative gradient like they requested. If they were just saying that find us the axis of symmetry, we was going to have another equation saying x plus c. So in this case we would say c1 and c2, right? Constant 1 and constant 2, right? And you see one is a positive gradient, one is a negative gradient, but the only requested that we calculate the axis of symmetry for negative gradient, so let's do that. So now it goes back to the first question, right? You need those coordinates, you need the intersection point for your asymptotes to calculate the axis of symmetry, because we go here on the formula, we substitute those values, right? So minus 2 is equals to minus, you have 1, I could say just brackets, plus c, right? And then that's going to be 1 minus 2 is equals to c, then this, what is this, minus 1 equals to c, and therefore, right, therefore you have y is equals to minus x minus 1, right? And that function is going to be a straight line, eh? It's going to be a straight line passing through these. Yeah, it's not drawn up to scale, but this point then it's going to be just minus, wait, if I y0, okay, y0, wait, let me see. If x is 0, therefore we have y be minus 1, so that means it must cross somewhere here. Ah, man. Yeah, so yeah, it will cross. I'm not doing this thing quite fine, man. Let me see. Okay, let me just do it here. X intercept y equals to 0, so if y equals to 0 I have 1 minus x minus 1, and then I have x being minus 1, right? And then y intercept x equals to 0, so I have y equals to 0 minus 1, so then I have minus 1. So that means it's minus 1 and minus 1, so this is minus 2, minus 1 is here, minus 1 is here, another minus 1 is here, right? Just saying. And therefore we're gonna have a graph passing through the something like this. Man, yeah, something like this, something like this, yeah, something like this. So of course the guy is not drawn up to scale, but yeah, it has to pass your intersection, it has to pass the minus 1 of the y value, the minus 1 of the x value, and this will be that axis of symmetry, right? Yeah, but the one with the negative gradient, of course. Let's see what the next question says. Next question: hence or otherwise determine the coordinates. Okay, let me say 5 1 4. Hence or otherwise determine the coordinates of a point that lies on F in the fourth quadrant, that is closest to point A. Yeah. So we're determining the coordinates of a point that lies on F, so it's on F, right? Yeah, it's on F, the hyperbola in the fourth quadrant. So we are focusing here, our focus is here, this is where our focus is, ne? Which is the closest to point A, right? That's quite very cool. So think about this one. It's the total is like 5 marks, so there's gonna be quite some work. So let's think about it. What is this question saying? Another thing that can give you clues, I wonder when you come across a question that you are having a hard time figuring out, perhaps what is it that I'm asked to calculate, you can look from the previous question the things that you calculated, because those things, they can sort of give you a clue as to how you can easily attack the question you have to answer. So yeah, let's start thinking. Cool. So here's a nice system, here's a nice system. So I think I didn't say this thing about hyperbolas and axis of symmetry. I didn't say it. But just like I said, think about the previous questions, what we were asked to do in the previous questions, and we'll sort of get a clue of how to attack this one. Right. Looking like when I was thinking, I'm like, probably it's gonna be the turning point of this. I mean, there's no like exact point which we could say it's a turning point, but it sort of just makes sense. Yeah, because here is A right here, right? So the point is gonna be somewhere there, right? And actually the closest thing you could possibly use here is what is this thing we were asked to calculate. So we're gonna use it, right, and try to find maybe the point of intersection for our axis of symmetry and the hyperbola itself, right? So let's do that. We have y for axis of symmetry, and then we have y for your hyperbola, right? And this is minus x minus 1, and this is minus 9x minus 1 minus 2, right, so cool. Now what do? It's the next question. We could multiply everything, right? We could multiply everything by x minus 1. All right, let's do that. So if we do that, then we have x minus 1, right? This side, let me already take out the negative sign. Maybe I will see that later, but no man, let me do it now. So I have positive x plus 1, and then my negative 1 is outside. Because this is a product, it allows me to do that. Then that side, I'm gonna have a minus 9, and I'm gonna have minus 2 into x minus 1. All right, cool stuff. So that means if I look inside, that is what difference of two squares, difference of two squared. So I have minus 1, I'm gonna have x squared minus 1, and I'm gonna have minus 9, that is minus 2x plus 14. So everything is just flowing nicely. So I'm gonna take everything to this side. That means this it's gonna be positive. So I have x squared minus 1, then I have minus 2x, then I have that's gonna be plus 5 from minus 9 and 14, and the last part I have 0 here, minus 2x minus 4, right? Yeah, does this makes sense? Does it make sense? Yeah. So this is a plus, man. This is a plus. Cool stuffs. No, let me look through, man. I might have done a mistake here. My hyperbola is fine. Minus 1. Yeah. Okay. I'm seeing the mistake. So this is where I made the mistake. This is 1, and I made it look like 7. Sorry for that. I just noticed. So then that means this is not gonna be plus 14. This is going to be plus 2. Alright, so I have minus 2 minus 1 multiplying, then it's plus 2. Whew. Then therefore I'm gonna have minus 7. Yeah, I'm gonna have a minus 7, and that means I'm gonna have a minus 8. Yeah, cool stuffs. So then factorizing these, I'm gonna have x, then I'm gonna have minus, so it has to be minus 4 and plus 2. I solve for x. I'm gonna have x is equals to 4, or x equals to minus 2, And looking at this value, looking at these values, the one that should be on the fourth quadrant, let's see, x values on the fourth quadrant, they are positive because this is the fourth quadrant. So the values of x here, they are positive. That means this is the value we're gonna focus on, right? And we're gonna ignore this one because it's either on the second or the third quadrant. It's either here or here, the coordinate we're gonna get. So yeah, we have the 4, and now to do the final part, I don't have space, so I'm just gonna do this. To do the final part, we're gonna take that -4 and we're gonna substitute it. Say y is equals to minus x minus 1, and therefore you have -4 minus 1, and therefore you have -5, right? -5, yeah, as the answer. Therefore the coordinate then is 4 and -5, right? So yeah, that becomes the point of the coordinate that is closest to this intersection. Yeah. There's this thing we're gonna do like later on called optimization. I think it's sort of, yeah, I think it can actually work here. Yeah. And I mean, another thing that one can actually do is you can try to answer this question by doing what? You can take it back before there was any shifting, right? Before there was any shifting, in that case, say g of x, you have -9 over x, right? -9 over x without the -1 and the -2 shifts, right? And you try to find the closest point to the origin, because in this case the intersection of your asymptotes is the x-axis and the y-axis, implying that the intersection is going to be the origin point, 0 0. Then you find the closest point to this function, right? To you find the closest point on the graph to the origin, right? When you do the work, you'll find that the point is 3, and yeah, so the point is going to be 3 and -3. And then now when you do the shifts, right, we're shifting 1 unit to the right. That means that is 3 plus 1, and we are shifting 2 units downwards, and that is -3 -2, giving you exactly what we have down there, right? And also you could use like what we did to find the closest point. This point, you can find it the same way we did find ours in here. Damn, yeah. Then the last question, this is the last question on the hyperbola. It says the graph is reflected about the x-axis to obtain the graph of g. Write the equation of g, right? I don't think maybe when I was discussing the content, I don't think I ever did explain like, what do we do in cases where your function is reflected about the axis. So it could be the y-axis, or the x-axis. So but let's look here. I'm gonna erase everything. So now something we should focus on is the x-axis. Where is the x-axis? I will draw straight lines there. Increase the font. This, oh my god, this, yeah, this is the x-axis. Damn. All right, this is the x-axis. And now if your graph happens to be reflected, so it's like we put a mirror there on the x-axis, what's gonna happen? So simply put, I'll use a different color, right? The positive, the horizontal the horizontal asymptote will be shifted about the x-axis. So we're gonna have 1 right here, right? And this one, it will be y equals to 2, right? And then the the vertical shift is gonna remain as it is because we are not reflecting along the y-axis. So you have that straight line, you know, which is a reflection of what? Of this q. It's the reflection of this. So we have it down there, up there, right? So another thing that's going to reflect, remember, you put a mirror. You did put a mirror here along the x-axis, right? What is it gonna show, right? This part of your graph is gonna show on this side, right? It's gonna show on this side, né? It's gonna show on this side, and then this part will now show on this side, right? Implying that the gradient, or not necessarily the gradient, but the value of a is going to be positive, right? I hope the explanation, it makes sense. I hope the explanation makes sense, but do say if it doesn't. Do say if it doesn't, and I'll do more problems like that where we are reflecting steps. So that means, based on what we said, G is gonna be now. Remember, A is positive, and we did nothing to the vertical asymptote, so it remains as it is. And then the one that got reflected. Also, I will show you why we don't do anything about the vertical asymptote. So the horizontal asymptote, it did, you know, reflect, but now on the positive, so we have a +2. One of the reason, like, because if I put a mirror along the x-axis, right, if I put a mirror, this straight line, right, that is here below, is still gonna show as it is, right? If I put the mirror here, it's not gonna show on this side of the quadrants on the side of the y-axis, right? It's still gonna remain on the side of the y-axis. That is why it doesn't change at all, unless maybe there was also another reflection along the y-axis. Yeah, so that is a hyperbola function. Now, yeah, I think let me post this video and make another one for exponential. Yeah, because 5.2, it's exponential functions. Now I'll see you there in a minute.